Okay, so again, we're graphing each 4 of these things in Desmos. Graph the first one, then see, well, what changes when we go to the second version. Okay, if you can determine a y, talk to those around you. What are you seeing that makes these differences? Yeah. If you actually say like PI, it should be the pi. I know, I love Desmos. Actually, Aubrey just brought up a good point. You can do two, like both of them at the same time. Too. Like you can graph more than one function, right? But if you want to throw like the opposite version in the second, you can have like your number 1 function and your number 2 function. So you could put both positive 5 sine 3x on number 1 and the negative 5 sine x on number 2, and actually visually see like this is the first one, here's the second one. It'll show you as many graphs on one function as you want. But they call this one graph. I'm trying to tell when you were going, okay? Okay, keep making notes, keep talking to each other, keep trying to figure out what's happening here and why. Yeah. Okay, finish up in the next like 30 seconds on this, and we'll talk about it. If you don't get all the way through, that's okay. I'd rather you're making some inferences than making none at all. As soon as we get through the rest of sine and cosine, the honors topics will be posted as well. Okay, so as soon as we're through the end of like graphing everything with sine and cosine, it should be probably by Tuesday or Wednesday of next week. Every single, like all honors topics for this section will be posted. And then we're probably looking at a test the 16th is where I'm at with it. So that's going to be 2 days before the end of the semester. It's going to be the Wednesday before we go on to break. With those 2 days kind of being like the 17th is the day everything's due. So it would be your like, you get to catch up in class day. And then if you're wanting to retake chapter 4 part 2 test, I'm going to let you do that in 3 weeks. That's not fair. Okay. So let's look at this first one. When you are looking at the graph of 5, and maybe pull this one back up on your Desmos, because again, I can't do it as pretty up here. But when you're looking at 5 sine 3x versus negative 5 sine 3x, did anybody notice something like super blaringly obvious? Yeah. Right. So it's almost like, if we can draw this out, if we specifically look at the axis, it's exactly what Daniel's saying. We are, instead of starting down and kind of going up, this was the first function, right? Like a normal sine function, it started down, it went up, like up and down, up and down, up and down. If you look at the negative version, so this one right here, let me get another marker for it actually. Same exact function, just it has a negative out in front of it. It still starts here, but it goes this direction, right? So we like to focus on the starting points of these graphs. Okay, and the starting point of this graph right here, instead of going up, it starts going down. So that's what that negative is going to do. Okay, it reflects our graph. Instead of going up this way, it's going to reflect it down, and you start going down first. So negatives reflect. You may have remembered that even just from like when you're even graphing like a, what would have been like a quadratic function, right? They either open up or they open down if they're negative. So any graphs you've had in the past likely reflected when they turn negative. Okay, so what does that mean for us moving forward? We've not yet talked about having a negative out in front of a sine function. Okay, that means when you have any, let me erase this top one. When you have any function at all that starts with a negative sign, meaning you have a negative a, you are going to have your first 5 points look like this instead. Okay, so we go down, up, then back to the middle. So the exact opposite of what you like had before. Okay, so again, when we're starting with that negative sign, we now go from the middle down and then back up. Okay, so that probably is something I would write down, because you're going to have that circumstance happen here pretty soon here. Okay, so what do you think that does to cosine then? Let me go ahead and get those two typed up. I'm only doing these on my computer too, because I am recording this for anyone that's not coming into the Zoom meetings. So we have y equals 1/5 cosine 1/4 x. Oh, wow. Oh, that's being stupid. We'll just go that. And then if I can type here. Jeez. If the projector worked in here, I would just project it for you guys, but it's not my best friend. Okay. So if we're talking about graphs of this one instead, it is the original one, again, starts up because cosine starts up, right? That original graph starts up, but not very high because we're only going up to 1/5. And it just kind of goes like this. Okay, so then the negative version of it takes that same kind of path, but it starts down here on that axis, right? And it still follows that same path, just in the exact opposite wave. So when we get a negative cosine function, so meaning we have that negative a, those first 5 points start here, 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 here and here. So instead of having a valley first, you have that mountain. I know it's super stupid, I call them mountains and valleys. It's the best way to kind of describe them. So the next thing we've introduced is having a negative out in front. It's one thing that I see people like mistake the most. Everyone's like, oh, I got my A and I got my B, I'm doing great. And they forget to reflect it. Okay, so before we even move on to talking about these last two, I just want to give you an example of graphing when you have a negative out in front. And this one I want you to actually do by hand. So we're going to get a little bit of practice of things that we should have been doing and knowing how to do by yesterday. I want to practice those again and add in this negative to it. So not on Desmos, actually by hand. Let's graph y equals -3 cosine. What do I want to do? Let's do this, 4x. This is one that was on the homework worksheet, and I want to make sure that everyone is good with that, that 4 when it's a b. Go ahead and graph this one. If you feel more comfortable checking yourself on Desmos once you're done, I'm good with that. Right? Never Desmos. On paper, guys, not on Desmos, on paper. These Chromebooks will be the death of me.
Number 2.5 over B. Never for that. And that's whatever that is. That's where the whole thing is. Got one side there. And then you put 4 down. Would be from.
So this B is the same B you had on is it gone? Oh, it's gone now. Okay. That was, oh. With it. Yeah, what is that light coming from? Is it Kelsey? Wait, wait. Kelsey, turn your head. Is it your earring? Do you have earrings in? Oh. I have no idea. It's gonna bug me. I know. This is the same B value that you had on one of the homework assignments. I thought this one was pretty difficult. No one asked any questions on it, so now I'm gonna put you to the test. Did you do it or did Desmos do it the first time around?
I don't even know how to use Desmos. I had to do it all by hand.
How did you know how to use Desmos?
No, I don't. I didn't know how to use decimals until now.
Oh, okay, I was like, you still don't know how to do it now, I was standing right here. Okay. Yeah. So what's your A value? Good. Okay, so what does that mean? And you'll label your y-axis. Good. Up three, down three. And then where can you tell me your first point? Starting off at? So it's negative. Label that first point then. Okay, so let's go ahead and put that there so we know we're gonna start there. Let's just not leave any room for error. So what's your B value? Good. So good. So good. And then that simplifies down to pi over 2. Good. So we have to take pi over 2 and divide it up into 4 equal sections, which kind of gets difficult with the fraction of dividing up. So how can I take pi over 2 divided by 4? You're super close. So when we divide by a fraction, we multiply by the reciprocal, right? What would be the reciprocal? 4. So you're opposite way. Good. So multiply by 1 over 4. And that will help you find each section. You're almost there. All right, here's my second. What? Oh, wow. You're the. I'm gonna go back. That's okay. I'm not blaming you. I would say, let's say tomorrow, by Monday. Good. All right. So what's my A value? Remember, we take the absolute value of it. It's 3. Well, it's technically -3, right? But we get 3 as that A value. My B value is 4. Very good. So there's a couple of things I like to do right away so that I don't start this off wrong. Because once I start getting into my B value, I start losing track of where I'm at. And I'm like, oh my gosh, I'm thinking of too many things. The first thing I like to go do is say, what's my starting point and what's my A value? Right, so this A value means that I go up to +3 and down to -3. Since it's a negative cosine, do I start up or do I start way down? Way down, right? This is my starting point. So I like to put that dot on my axis so that I don't come back and make a stupid mistake of writing it like a normal cosine function. Because I totally will do that all the time. You start forgetting that it's negative. If my B value is 4, it's not 1, so that means it's changing my period length. So I need to find the new period length. We do that by taking 2 pi over b, okay? That might be a little equation you remember that you're like, that thing is in there somewhere, but I don't remember what we did with it. If I take 2 pi over my b value, that is 2 pi over 4, which simplifies to pi over 2. So what we're saying is that this entire cosine function has to be done with, like one full period has to be over with by pi over 2. I'm trying to draw this to scale. Hopefully, if you guys can't see it in the bathtub, I'll just blow it up and draw it not to scale. I'll move it over a little bit, so I have a little bit more room. I try to draw mostly to scale, but it never ends up happening because then you can't see. So I have to have 4 equal sections between here and pi over 2, which means I need to divide up pi over 2 by 4. Do we know how to divide a fraction by a whole number? Well, you know how to, but you probably don't love to do it. Yes, very good. What's the reciprocal of 4? Good. 1/4. It's technically 4 over 1, right? So pi over 2 times 1/4 equals pi over 8. That means each individual section needs to be pi over 8, pi over 8, pi over 8, pi over 8. We can literally count up. We can start at 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. I say write first, simplify later. I now can go back and say 2 pi over 8 simplifies down to pi over 4. The rest from I leave, right? You can start in the beginning and just count your way up. That's my easiest way to tell you how to do it. We started way down here at -3. Second point, third point, fourth point, fifth point. Well, and obviously it does keep going, but I'm not going to keep drawing the rest of this because it's just going to get grosser and grosser. Questions on any of this? Are you guys getting closer to understanding this? Okay, so all we did today was add in a negative value. Coming up on Monday is when stuff will really start to get a little bit more difficult. So if you're truly not understanding how to graph those negative a value and a b value, I would suggest asking for some help over the weekend. Or maybe rewatching a video that maybe you fell asleep on during Zoom or something like that. Fell asleep. Maybe you're watching, like playing video games. I don't know.